Hello everybody, welcome back. Today we're doing the second half of 5.4, the normal distribution part 2. We're just going to be comparing data. So the two baseball teams, the team with the men had a mean of their carry-on luggage of 6.35 kilograms with a standard deviation of 1.04 kilograms. The women's was the same, 6.34. And the standard deviation was smaller, 0.59. So we're going to sketch the graph. So the men's, obviously, there's more of you'll see that the standard deviation is larger, so there's more of a dispersion of the data. And with the women, the same mean, but standard deviation is almost half the size. So therefore, you'll notice that it's a little higher for dispersion, and it goes out like this. And we did this in one of our earlier diagrams, so it's not as dispersed, the data. Okay, so there's a sketch. I did it for you just because it is hard to sketch. So I did the standard deviation. The blue you can see is plus or minus 1.04, and the red, the mean is the same, but the standard deviation is smaller, so the data is not as dispersed. And it's a higher because obviously it still has an area of 100%, so it's just a little higher and more narrow. So this is one that is a little flatter and more wide. It has a little more width. How would the graph change if a woman added metal or the souvenir to the bag with a combined mass of 1.15? So they want a metal and they have a souvenir. So the mass increased by 1.18. So what happens is the means are going to change. So you'll notice that this is shifting to the right. And we did this in one of the earlier videos as well. You'll notice the shape stays the exact same, but it just slides down a little one. Okay. So now we're going to analyze the data to solve a problem. So we've done this in a previous video as well, how to plug in the data. But I'm going to do it with you again. So we're going to plug all this data into our graphing technology. So we're going to open up our graphing calculator. All right, and we're going to plug all this in. So I did second function plus 712, second function plus 712, reset all my data, hit clear. So remember we hit stat, and we hit the first one, we hit 1 or edit, and it'll open up the list for us. We'll start adding the data in 1.1, 1.7, 1.7, 1.8. 1.9. Alright, and I'm going to do this all with you. I'm just going to pause the video and enter the rest of the data until we get to the end. So I've added all the data in 50 pieces of data, and the last one is 3.7. Hopefully everything's in correctly. And remember what you do is you hit stat. And then you're going to hit over to calculate. So hit right, and then you hit 1 bar stats. So hit 1 or enter. List 1 is what we need. We already have that. If you need to change it, you can just hit second function in your numbers to get the list, but it should be okay. Hit calculate, and we have our mean. So we're interested in the first one here, the mean. This is the sum of the numbers added up, if you were doing it by hand. We're not interested in the sample standard deviation. We're interested in the sigma here. And we notice n is 50, so we know we've entered in the 50 pieces of data. We also have the median here. Median is 2.55. That's because if you look up at your list, it's 2.5 and 2.6 are your middle pieces of data, and then you take the average of those to get that. So we'll write in our information that we have. So our mean we calculated to be 2.526. Our standard deviation, remember that's the one that looks just like that symbol that we want, 0.482. The second one there. And the median was, remember, this number here and this number here are the two middle pieces of data, so halfway in between both. You just take the two of them, add them together, right? And divide it by 2. Or you can just write it in as 2.55. It's either way, like if you use the calculator, it's there anyway, but it's halfway between here and here, right? So now what we're going to do is we're going to figure out what we're going to use for our lifespan. So there's a number of ways you can approach this at this point. It's up to you where you want to put your frequency at, but we'll do 1.1 to 1.5 if you wish. we'll go 1.1 up to 1.5. And then we'll go, and again, this may be different from someone else, 1.6 up to 2.0. And 2.1 up to 2.5. And now some people will just put the 0 here and then just put the 1.5 up, but don't include it. It's up to you. It's really, it doesn't make a difference, to be honest. 2.6 up to 3.0. 3.1. Oh, 3.1 up to 3.5. And 3.6 up to 4.0. Okay? Then the frequency, how often that occurs. So this is here once. 1.6 to 2, so it's 1, 2, 3, 4, 5, 6, 7. 2.1 up to 2.5, so we got 1, 2, 5, 5, all these, so it's going to be 15, 16, 17. And then 2.6 up to 3, so it's going to be 5, 10, 15, 18. And 3.1 up to 3.5, so it's 1, 2, 3, 4, 5, 6. And there's only one there. So to create this histogram, I'm going to have 6 bins, which I have here. I listed from 1.1. I made each bin worth worth a half, right? Approximately 0.5, because it said create a frequency table using the standard deviation. So approximately 0.5. So I started at 1.1, went to 1.5. You could also call this 1.6, not including 1.6, but I just put 1.5 because our data was one place after the decimal. So you could put this as 1.6 and not inclusive of 1.6, but if you don't want to be confused, just put 1.5. So that's why it shows 1.1 to 1.6, but it's only the values here are only 1.1 to 1.5. And then the next one starts 1.6, not inclusive of 2.1, and so on. Okay? So I have the histogram here, and we have a diagram showing the frequencies, as you can see here. 1, 7, 17, 18, 6, and 1. All right? Next, what we're going to do is we're going to look at the longevity of each battery, or each cell phone, sorry, or each smartphone, I guess, using plus or minus 1 standard deviation. So we take the mean right here, and again, the mean can be used mu. It just has to do a population and sample data, but that doesn't really affect us. But you can put mu here or standard or the X with the line over it again. You'll learn more about that if you take another stats course, but for now, either one is fine. So plus or minus 1 standard deviation. So I'm going to do the minus first, and I get 2.044. So approximately 2. And 3.008, which is obviously approximately 3. And then within 2 standard deviations, I get 1.562. And within 2 standard deviations to the positive side, 1.49. Okay. And within 3 standard deviations, it's 1.08 and 3.972. So I'm just multiplying this by 3. And then subtract it from here, and I get these values. Okay? So, these are going to be our values of where we look at how many we have. So we taught a total of 50 pieces of information, 50 pieces of data. So if I were to calculate the percentage, remember we're looking at the 68, 95, 99 rule, right? So anywhere close to that we can consider normal distribution. So what we'll do is we'll count up how many fall from 2 to 3, right? So remember, anything that falls a little more than 2, a little less than 3. So we won't include 2.0. We'll include everything there. And we won't include anything more than 3.0. So this is going to be essentially, we're looking at the values from 2.1 up to and including 3.0, right? So we look at here, and that's these two values here, right? So 2.1 up to 3.0. So that means we had 35. So 35 out of a total of 50. Multiply that by 100, right, to get the percentage, and that's equal to 70%. So pretty close to 68%, right? It's never going to be exact. Those are estimates. And from 1 decimal, now obviously this is 1.5, so we can't go out, we can't get any lower than 1.56. So our values are going to be from 1.6 up to and including 3.4. Including 3.4, or we can go to 3. We can raise it. We can round it to 3.5. That's fine. All right. Again, these are just estimates, and that'll take us for all these. So the fraction is going to be 48 out of 70, which ends up being 96. Now, like I said, if you were to round that down and you didn't include 3.5, there's no 3.5 anyway, right? So we can do it up to including 3.4 if you rounded that down. It doesn't make a difference here. Again, these are estimates just to see, does it look like we have a normal distribution, right? Okay. And then obviously from 1 up to 4, that's every piece of data, right, that we have. So all data, so that would be 50 over 50, which is obviously 100%. It's obviously 100%. So these are very close to our 68, 95, 99.7 rule. So based on that information, yes, it is a normal distribution curve. It doesn't have to be exact, it just has to be in the vicinity, pretty close, but like I said, it doesn't need to be exact. Okay? So our final question says, if Shanny purchases this cell phone, what is the likelihood that it will last for more than 3 years? So more than 3 years are all of the data. So 1, 2, right? All these here. And we can do that using our percentages, right? So more than 3 years, what is the percentage of data that falls in there? All right? So if we look, the longevity within 1 standard deviation, we notice this went right up to 3. So this here is the 68% rule. So let's go up and take a look. So 1 standard deviation was up to 3. So it's everything from here down. So it's 50% plus 34%. So that's 84%. Right? So to get what we need, the likelihood that it will last for more than 3 years is 100 minus 84%, which is equal to 16%. So there's a 16% chance that this phone will last for more than 3 years. All right? For more than 3 years. And we can see that this is very close to actually what it would be, because we had 7 out of 50, which is actually 14%, right? So very close. So using normal distribution, like I showed you there, it's 16%. So there's the homework. Page 252, number 5, 7, 9, 12, and 13. In the next video, we'll start 5.5 z-scores. Thanks for watching. I hope the videos are helping. We'll talk again soon.